From this we get the value of a, that is 1 by 2, the value of b, that is 0, and the value of c, that is minus 1 by 2. So we have t equal to k into under root L by G. I mentioned that this method works with some limitation, that is, there are some limitations which must be noticed. First of all, it works only when the dependence is of the product type, which is the case with our example. In our example, the relationship is t equal to k L A M B G C. Clearly, the relationship is of product type. Again, in this example, we are not able to calculate the value of k. Why? Because k is a dimensionless quantity. So, numerical constants cannot be deduced by this method. Again, by this method, the equations containing trigonometrical, exponential and logarithmic terms cannot be analyzed. So while working with this method, you have to consider these three limitations. Now let's take some more examples on dimension. Let's take this relationship, I equal to a into e to the power minus alpha t. Here t is time. Now can you tell me what is the dimension of a and alpha? T is time. An exponent is meaningful only when it is dimensionless. That is, exponents are always a dimensionless quantity. So the dimension of, or rather dimension of alpha t should be dimensionless. Now t is time, so dimension of t is t. So dimension of alpha should be t minus 1. Again, e to the powers minus alpha t is a dimensionless quantity. So we have the dimension of a equal to dimension of I. Here I is current. So the dimension of a is same as the dimension of current. Now let's take another example. Y equal to a cos t by p minus qx. Here y is displacement, a is some unknown quantity, t is time and x is position. P and q are variables, as is the case of a. Now we have to find the dimensions of a, p and q. Again, this trigonometrical operator like sine, cos, tan is meaningful only when it is operated upon some angle. So this quantity under bracket must have dimensionless quantity, or rather must be a dimensionless quantity. So Qx and Typ both should be dimensionless quantity. Now x, the dimension of x is L, so the dimension of Q is L minus 1. Dimension of P, again T by P must be a dimensionless quantity, and dimension of T is capital T. So dimension of P is again T, so that T by T is a dimensionless quantity. Again, this quantity, that is cos T by P minus Q by X, sorry, T by P minus Qx is a dimensionless quantity again. So if this equation has to hold, the dimension of A should be equal to the dimension of Y. So the dimension of A is L, that is dimension of Y. Let's take another example. X equal to A plus BT plus CT square. We have to find the dimension of A, B and C. This time, in this case, dimension of all the four terms should be same. We have seen that. Now x is position, so dimension of x is